Hello. We're going to start today's lesson over section 5.5 by doing a little bit of review. These problems actually go back a few chapters to when we talked about literal equations. Remember, we talked about you can solve for any variable in a literal equation. So I'd like you to try the mixed review. So if you want to pause for a minute and try those, and then I'll have the answers up for you and see how you did. So hopefully you paused and had a chance to kind of work through number 1 and number 2. I have the answers listed here. For number 1, since it's all multiplication, you can actually move over the 7 and the x together by division. So you would end up with y equals z over 7x for number 1. On number 2, I started by dividing both sides by 6 to move that over. Then I wanted to move the x, so I subtracted the x. And I still have to get rid of the negative here, or the -1 in front of the y. So I have to divide both sides by -1, which really just changes your signs. So that's why you end up with y equals -c over 6 plus x, because that -1 changed the signs. So just a little refresher there, maybe a little bit of different types of problems than we had done previously. So now moving on to our topic for today, we're going to be talking about standard form. So this is another form for writing equations that are linear. So the standard form of a linear equation follows this formula. So ax plus by equals c. Notice a, b, and c are real numbers, and a and b are not both 0. You can easily determine the x and y intercepts when an equation is in this form. Each intercept occurs when one coordinate is 0. So when you substitute 0 for either of x or y, one of the terms will be in standard form, and this leaves you an equation in one variable. So you can either solve for x or solve for y, and that would determine your intercepts, either your x-intercept or your y-intercept. Remember that intercepts are where the graph crosses either the y-axis or the x-axis. So just to refresh you there. Let's look at an example here that's kind of already worked out for us. In these few examples, they say, what are the x and y intercepts for this equation? So what we're going to do is we actually have 2 problems. So I'm going to just kind of number those. The first problem wants you to find the x-intercept first. So that means you're going to substitute 0 for y. So when we plug in 0 for y, that's going to cancel, and that leaves us with a one variable equation. So we can solve and get x is 3. Then the second step is we want to solve for the y-intercept. So again, we're going to substitute 0, but this time we're going to substitute it in for x. So now the x cancels. Now we're left with a one variable equation with y, and we can solve for y. So this tells us that the x-intercept is going to be 3, and the y-intercept is going to be -2. So that is where the graph of this equation would cross the x-axis and the y-axis. It's also a really quick way to graph an equation. So moving here to a couple of examples. In the first example, what are the x and y intercepts for this equation. And then in the second example, I'll have you try that on your own. And you can then we'll pause it. You can try it on your own, and then you can check it with me. So first we'll do this first one together. So remember, you're going to plug in 0 for x, and you're also going to plug in 0 for y. So if I plug in 0 for x here, I'm going to be left with negative 6y equals 60. If I plug in 0 for y, that's going to go away, and I'm going to be left with 5x equals 60. So now I have each equation with one variable that I can solve for. So I would divide here, and we would end up with y is negative 10. And on the other side, I would divide both sides by 5, and we would end up with x equals 12. So there are my two intercepts. Now, a lot of times they might write these as ordered pairs. So since we plugged in 0 for x to get the y-intercept, I'm going to put 0 for x here and negative 10. So that would be my ordered pair for my y-intercept. And here I plugged in 0 for y. So 0 would be in my y value. So there's my ordered pair for the x-intercept and my ordered pair for the y-intercept. A lot of times they will write them as ordered pairs, especially if you're going to be graphing. Okay, so you try the next one here. Find the x and y intercepts for this equation and go ahead and pause. And then in a few, minute or so when you finish, unpause and you'll be able to see the solution. So here is the solution for the next example. You can see that I plugged in 0 for x and 0 for y, so I have my two problems. And we solved. So your x-intercept should end up being 4, 0, and your y-intercept should end up being 0 and 3 over 2. And we can just leave it as an improper fraction for now. If we were graphing, I'd probably go ahead and change it to 1.5, but for these purposes, this is fine. Now, we can graph linear equations in standard form simply by plotting these 2 points. So here's an example where we're finding the intercepts, the x-intercept and the y-intercept, and then we are graphing those points and just connecting those together. So really a quick way to graph something if you just need to quickly see the graph of that. So let's just do one of those here. In this example, what is the graph of this equation? So we're going to quickly solve for the intercepts and just graph those. So again, we're going to plug in 0 for x and 0 for y and have our two equations. So we'll have 2x equals 20, or we'll have 5y equals 20. And then, of course, we'll solve each. So here x is going to be 10, y is going to be 4, and I know that those are points. I know this one's on the y-axis, so I'm probably not going to write it as an ordered pair. I'm just going to go on the y-axis and make a dot here at 4. Same thing here, go to my x-axis, make a dot at 10, and then I would just graph those relationships there. I don't know if this will let me draw a straight line, but at least helps me out a little bit. Kind of a fancy tool here. So I would draw along my ruler. Yay. Okay. So then you would have your line, It is nice if you can use a straight edge, and I don't always do that in class, but I have time now to kind of play around with it. So example 3 is, what is the graph of this equation? So here we have an equation of a vertical line. If it's vertical, it's going to be x equals a number. And if it's horizontal, it's going to be y equals a number. So there's an example. So that's just kind of a quick way to know if it's vertical or horizontal. So in this problem, I know 4 is my x-intercept, so I would put a dot at 4. I also know that it's a vertical line, so I'm just going to draw a vertical line. Use my fancy tool here, maybe. So I will just trace along there and draw my vertical line through 4. So there we have the graph of x equals 4. One thing to mention, that when you have a vertical line, remember we say that the slope is undefined because you would have 0 in your denominator of your ratio. And for horizontal lines, we know that the slope is always going to be 0 because there's 0 in the numerator of the ratio. So just something to keep in mind there for later. Now, transforming to standard form, remember back a ways we talked about the formula. So we have to know what standard form is. Again, I'm going to just kind of write it up here. AX plus BY equals C. So if we look here, we must use whole numbers, so we've got an issue with the 1/3. So at some point we're going to have to get rid of that, and then we're going to have to transform it so it looks like this. I'm going to go ahead though and stop here because my video time is going to run out soon, and I will have to make a part 2 video. Okay? On to the next one.